Welcome everybody to today's webinar. We're going to be talking about backup electricity systems today. My name is John Hay, and I work for Nebraska Extension. We're going to be talking about backup systems, and those systems are installed in a variety of scenarios for a variety of different purposes and goals. And those designs then are very specific to the situation. And that's one of the reasons we're doing this as kind of just a discussion, is that we can kind of move around through all the different scenarios and talk about some of them and the pros and cons of some of those. Our previous webinar, we had some homeowners that had initially installed solar, and then they had an outage, and then they added batteries to their backup. And so we talked about their goals and their processes and learned a little bit about kind of their case study or their situation of how that went. When most people install solar, that doesn't necessarily give them backup power. In a power outage, a grid-connected solar array will, behind the meter at a home, will shut down and just wait for the power to come back on. There are a few exceptions. We talked about one of those last week in the webinar, so go check that out in the recording. But today's webinar, we're going to be talking with John Dixon of Dixon Power Systems. John has spent 20 plus years installing solar, small wind turbines, battery backup systems, backup generators. Scott Williams is with Greentech Renewables, and he is an expert in solar and backup battery systems and their components, as well as he previously taught at Creighton. Is that right?
Yeah, that's right.
Taught energy systems at Creighton. So we have a couple of experts here that I think we're going to have, much more information than we have time to share, but we're going to get to a bunch of it and see how it goes. So to start off, let's start talking about what are some examples of what people are trying to accomplish when they want a backup system. So think about kind of some conversations you've had with people over time, and what are some things they're trying to do with the backup system?
John, do you want to go first?
Sure. When folks call me and they want backup power, they're usually looking at, I want to run my house, and then you get down to, well, what do you want to do with your backup power system? So I generally suggest to people that you need to define your outage first. So what do you think that outage is going to look like? Sometimes people are only concerned with a day or two. Sometimes people are concerned with a week or even longer. And then when you've got that kind of an idea, then you look at, well, okay, what do I want to operate? And as the Myers kind of indicated when they went through an outage, that it was not pleasant. And so afterwards, they decided to add batteries for their backup style. And then they defined what they wanted to have during that outage. So if you've been through a recent outage, you probably have some of that stuff in your mind, what you wish you would have had, and that's what you can look at.
Yep. Let me back up and do a 1 minute introduction. I work with Greentech Renewables. We are a wholesale hardware distributor. So we are not installers, builders, developers, contractors. We work with installers, builders, developers, and contractors, folks like John and others around the area in eastern Nebraska and western Iowa. We provide hardware to build solar and storage projects at the residential and commercial scale. So usually I talk with our clients about trying to bring products to market that will be a good value proposition for their customers, whether that's residential or small business. And I think that it's important to always have that conversation about what are the essential loads, because I think sometimes there's some misconceptions. And one of the ones we talked about last week was the idea that if you have solar panels on the roof, then the stuff in your home or building business will run when the grid is down. And that's not necessarily the case, right? So in order to be able to provide backup energy and power, you need to be able to have a little bit of storage. So having solar panels alone doesn't keep the lights on if there is a grid service interruption. You need to also have batteries. And then there are two main criteria there. There is power in kilowatts, watts or kilowatts, and that is the instantaneous load that you can serve. And then there's energy in kilowatt hours. That's how long in time you could serve that load. So a hair dryer might be 1,500 watts. Your oven might be maybe 4,500 watts. A light bulb, an LED light bulb, might be 2 watts. And so having reasonable expectations of what you can power for any given instant and then how long you can power it is always the most important conversation when I'm involved in talking about backup energy solutions. There are about 6-ish things in people's homes that are sort of very large loads, and then there's everything else, which is pretty small. So the main stuff is air conditioner, which uses quite a bit of electricity. If you have electric heating, whether that's space heating or heat pumps, if you have an electric water heater, or even better, if you have a heat pump electric water heater, cooking, if you have electric cooking in your oven or stove, and then clothes drying, if that's electrified. And then the last one is transit, if you have electric vehicles, right? And those are large loads. And then the other stuff like TV and lights and Wi-Fi, those things are all fairly small. But those 6 are the big ones. And there's always an important conversation to balance. What do you want to be able to power? How long do you want to be able to power it? And then also, what will that cost?
I really like both of those comments, particularly, let's start with John when he said define your outage. I think that's really a big one. You know, how long am I trying to create this backup for? Am I trying to create it for 2 hours, 2 days, 2 weeks, indefinitely? And then the part that Scott really keyed on, which was essential loads. So let's build on that essential loads discussion just a little bit. If you were to recommend to a individual, and thinking about this being a residence or a small business or a farm, something like that, we can being a little broad in that. But if you were to recommend to them some ideas on how to begin making that list of critical loads, and what might advice you give them?
I guess I can start. So for me, essential loads are what do you need to stay in the home during your outage scenario, whatever that time frame is, to be comfortable, so that you can be at home and you're not part of the problem of this outage going on. And so with that, it's always going to be heat, water, refrigeration, and obviously some lighting. So those are kind of the top ones. Now it comes down to, well, how are you going to accomplish that? Well, now you need to know more about that particular customer. But at least in my mind, those are the categories that are the ones that allow you to stay home. Now, customer might expand that, to whatever you want, and all of that's possible. But those are kind of the starting points.
Yep. And in one of those in particular, especially, right now, tomorrow and through this weekend, we are in a potential power outage situation with an extreme weather event. The temperatures will be very low. Should be further south of us that's going to have most of the problems. We should probably be okay here. But if it was 0 degrees outside and your power was out, you're going to need heat, right? And if you have electrified space heaters or heat pumps, then you have an electric path directly to heat. If you don't, maybe you have a furnace. And I think people don't always realize the furnace provides heat with gas, but it moves the heat around through the home with an electric blower, right? And so if you could power the electric blower, you can still heat the home in an electric outage. And so that's one of the things I think about this in my own home. I rent, so I can't buy solar on the roof. I can't install batteries because I don't own the electric infrastructure. But I think about that, and I usually come down to, in an outage, I would want to have enough electricity to keep that fan blower blowing so that the furnace could make heat and we could stay in the home. That becomes my number one thing. And then after that, I'd like to have a little bit of light. Those are the 2 things that I would like to be able to have in a cold weather outage, which is the one I've experienced in the past. So that's the one that's right on top of mind for me.
Yeah, this is really good. And we discussed last week, some different ways that there are alternatives to different things. So there are alternatives to lights, and do you prefer that over something else? But making that list is really important. So when would it be useful for somebody to go deeper and get tools like energy monitors or something like that? Are there scenarios where that would be valuable?
When you're talking about backup power, sure. But a lot of times backup power is obviously it's a shorter period of time you're looking at. It's not off grid, your backup. And so you still do have to design all those loads and come up with a number. And then from that, you can decide whether you need to do some monitoring. If they had some really complicated loads, you might have to do some monitoring. But for the most part, you can calculate those loads. They make their list of your loads. You can put what the wattage is, what the surge is, and then you can come up with that. But you can do monitoring, that just does it for you is all.
I think an important consideration is monitoring, but then also there is a trade-off between user behavior and smart electronics, right? So I will tell you, if you have batteries, I wouldn't recommend trying to cook a turkey in an outage, right? Because that oven is just going to suck down the electricity, and you could have sized batteries that should have lasted for maybe 24 hours if they're just doing lighting, right? And but you turn on the oven and suddenly 24 hours becomes 90 minutes of electricity, right? And so user behavior is don't turn on the oven during an electric outage, right? And you can balance that against, well, maybe I use smart features of a smart circuit breaker panel or some other types of monitoring and sort of intelligence to control the energy usage. And you could tell it, hey, if the battery gets down below 50%, turn off these large circuits. And if it gets down below 20%, turn off these next circuits. The balance there is the smart electronics at cost. And so is user behavior sufficient to be able to extend your battery to do what it is you want to do? Are you going to be able to know it's 100 degrees outside and the power is out, so I know I can't turn my air conditioner on? Or are you going to want a little bit of backup, smart electronics to help you say, hey, you're using way, way more energy than you probably should in this outage. You're only going to have an hour of backup here if you don't turn something off. I'll turn off that air conditioner for you.
And that's a very good point. The other thing I would add to that is that should be all in the design originally. So
Yeah.
if you're designing a system for backup and the oven was added to that system, then the designer should have put in that you can run that oven a certain amount of time. Because obviously if an oven was put in, the customer said, I want the oven. So I don't know that. So anyway, that just is a clarification there. So
yeah. And there are different ways to accomplish that with respect to hardware. You can have an entire smart breaker panel, or pretty commonly what people end up doing is doing a backed up loads sub panel. And so the things that are on that panel might be the backed up stuff. And then the stuff that's still up in the main maybe is not getting backed up. And you can provide that battery backup power to just the circuits that are on that sub panel. And that there's a little bit of cost with wiring a sub panel in to do the backed up loads, right? But it has the surety of, well, I know I can't turn the stuff on that's going to cruise through my battery, in minutes that I don't want to because it's not on the backed up loads.
Let's start talking about hardware just a little bit. Let's kind of maybe build this up just a little bit. Batteries can be backup and they can be charged by the grid. Batteries can be backup and they could be part of a solar installation included that. Backup could be a backup gasoline, natural gas, propane, diesel generator, or something like that. I'm not sure I've seen as commonly small wind turbines into a backup system, mainly because small wind turbines have high maintenance issues, and so they're not as popular, as well as their expense. But let's talk about let's list some of the most common backup systems that you maybe have seen or work with, and maybe list a pro or con of each of those.
Yeah, I think you're right with the notion. I want to back up and reiterate what I said before, which is that solar generation can make power when the sun is shining on the array, but it only functions to make power when it is grid connected, essentially, without some storage, right? So your real backup is focused around dispatchable power, stuff you can count on regardless of whether the sun or a cloud or night so batteries are sort of the core of that backup capacity, and then generators are the other piece, right? And there are trade-offs there. The solar array, you can buy electricity from a solar array on your roof for less than you buy electricity from the grid every day of the week, every week of the month, every month of the year. You can buy electricity for less from a solar array, right? So the solar array has the capacity then to help save you money on your electric bills and over time pay itself off. Correspondingly, the batteries that can store that energy are an investment in resiliency. And it's sometimes frustrating to me because anytime solar or solar and storage conversations start, people are laser focused on payback periods and ROI and break-even time points. But when you talk about a generator burning a fuel or a combustion generator, somehow nobody ever asks the question, what is the break-even period on my generator? Because the reality is, it's never. A generator will never, ever pay itself off. It's a resiliency investment. And so I think that's an important framing for what batteries are. Batteries are like the generator, except that the fuel is free and delivered to your house every day of the year, forever, through the solar panels. And so the battery is kind of like the generator, and the solar array is kind of like the fuel.
Right. Yeah, I agree 100%. And the payback thing with renewables started 25 years ago when I first started. I would go to all sorts of conferences, and that was always the question, what is the payback? Well, payback comes in different forms than just financial. So when I talk to people about backup power, in my mind, there is no financial, well, to some degree, no financial payback. Um, there is, of course, but it's not, you can't calculate it. But backup power is an insurance policy. You're buying an insurance policy. So you say to yourself, how much insurance do I want? So that's where you go through what's your outage scenario, what do you want to back up, all those calculations, all those figuring, and then that's what you buy. If you want to back up your whole house, it's going to be an expensive insurance policy. If you want to back up your well, then your gas furnace and a couple of refrigeration, it's going to be less expensive. Now, generators, are always the least expensive option. Home standby generators are probably the number one installed thing for backup. And yes, it does not have a payback, but if it allows you to stay in your home during an outage, stay warm, keep your refrigeration going, allow your family and friends to come and hang out there, that's a payback. And that's always been a payback. And that will apply for any of the technologies. If you want to add batteries, that's fine. That works great. But there is no payback, financial payback. You're buying an insurance policy, just like cars, homes, all that kind of stuff. So that's where that payback thing comes in. But for sure, generators are the number one deal. They're the least amount. You can back up more items with it. You can run as long as you have fuel. Fuel for me, a generator could be portable, but for the most part, they're home standbys running on natural gas or propane. So you typically are going to have long run times. So it gives you more flexibility. Batteries are great, but you got to remember, you got a limited source of capacity. And when you go into your backup scenario, you have to ask, but so do you want to back it up through the winter? And
Yeah.
there's always yes. And so how does solar perform in the winter? Well, of course, it's the worst time of the year for solar. We get half the generation, and we can easily have 10 days of overcast where you get no production. So now when you're looking at backup power, if your backup scenario was, oh, I just need to get through one day, well, it's not hard, depending on your items, to do that with a battery and no solar.
Yeah.
If you say, I want to go a week, okay, now you've got some solar, and as Scott said, you already bought the solar, so it's giving you other benefits, but now you add the battery. But you got to have some sunshine. If you don't have sunshine, like we're not going to have tomorrow, and we're not going to have Saturday, you could potentially run into a world of hurt. So what do you have to do then? You have to add a generator to the system. If they're getting into longer 7 days, I want to be able to run 2 weeks, whatever the outage is, you're always going to have multiple generation technologies to carry you through that kind of a thing.
Yeah, for sure. I agree with that. One of the things that I think about is there is at least one example of direct financial payback on your resiliency investments. And Alan and Nancy mentioned it before. And it's the easiest one to think about is when the electricity goes off, the clock starts on your fridge and your freezer. And at some point, all the stuff in your fridge and all the stuff in your freezer has to be thrown away. And how long is that? It kind of depends on how good your insulation is and whether or not you open the door. But at some threshold, somewhere in the 12 or 18 hours kind of range, right? Everything is a loss and it's all thrown away. And if you got half a cow in your deep freeze, I mean, not only is it a loss of a couple $100 at least of beef, but also now you got to deal with a half a cow that's rotting in your basement or your deep freeze, right? And so the financial opportunity there is, I don't know, how much food do I have that I would lose? And that's one easy way to try to think about this is what my insurance policy as John sort of described it, is covering. It's covering the loss of everything that I've got in a fridge or freezer. Is that worth something to me?
One of the comments from the Myers last week that I really appreciated was sometimes it's not always about quantity of food lost, but what that food is. In this case, they're gardeners, and that was their food, and so it has a higher value to them. And again, this is where John says not everything has an easily calculated monetary value. Some of it is got a value that is intrinsic or personal. So let's move into just a little bit more technical detail. I don't want to get super deep, but I want to start, at least hit on some of these things. Let's just talk a little bit. Let's stay in the battery world a little bit, or the solar and battery world a little bit, because that's a pretty popular discussion point. And let's talk a little bit about AC coupled systems versus DC coupled systems, and kind of maybe the pros and cons. So maybe a brief description of them, and then pros and cons of those two types of scenarios.
Like, whoever wants to go, I can go, I guess, shortly. So when you have a battery system, you're going to have a battery, then you have to have an inverter, which takes that DC voltage from the battery and converts it to AC voltage, alternating current, that we use in our homes. So when you say DC or AC coupled, a DC coupled solar system is just solar panels coming in at their DC voltage and being connected directly to the inverter or charge controller, charging the battery. When you talk about an AC coupled system, you're talking about a solar system that's solar panels. It's already got its own inverter. It's producing AC output, and that would be connected to the same AC output as the inverter. And so that's a brief description. As far as pros and cons, AC coupled, for the most part, I don't know when you would necessarily design a new one that way. You could, but if you've already got an existing solar, like the Myers did, and then you go to choose to add a battery system, then you could AC couple that existing solar to the new battery-based system. DC coupled is, for the most part, if you're looking at common inverters today, they're all shifting more towards the all-in-one inverters, where you have the inverter, charge controllers, everything in one box. So those are all DC coupled. You bring in DC to those. They have a port to do that. You can also bring in AC coupled. It just has a few more caveats, a few more limitations, a few more things you have to watch. But AC coupled, you're adding a second inverter that you may or may not need. So typically in a new installation, you may not do AC coupled. But
yeah, it's worth, one technical point is worth keeping in mind that when you turn direct current DC into AC, there are some losses, right? There are round trip efficiencies. And so one of the main points that people bring up about DC coupled systems is you have less loss through conversion. So if you have DC from the solar and you can put it directly DC into a battery, you don't have to turn it into AC and then back to DC, because the solar only ever makes DC at the panels, and the battery is only ever DC at the cell, right? So if you can take DC from a panel and put it to DC in a battery, there can be some round trip efficiency gains. They are non-zero, but not enormous. I don't usually think that that is probably the driving factor in an investment in these kinds of systems for the most part. I consider it very similar to a conversation between microinverters or string inverters on a solar array. There are some subtle differences between one or the other, but I don't usually think it's the main driving factor of system design or a choice to make an investment in, solar and or backup with batteries. There are subtle differences, and it's worth knowing what they are. Yeah.
I think it's just really important for them to kind of understand that there are some differences, because everybody's system is going to be a little different. Did they have solar to begin with? Did they add it at the same time? Did whatever it is, and there are lots of ways to do it, and there's lots of right ways to do it. It's just they're different based on what's going on uniquely. Let's talk a little bit about let's think about it from the perspective of the user. So they've got a backup system installed. And this, we can imagine this as a backup system that's a battery or even that's a backup generator. The power goes out because there was a winter storm. And what happens? What does it just automatically turn on? Do they have to do something? Just talk about that a little bit. And if there's different scenarios, that's fine. But
I'll start with the one that I'm most familiar with, which is a hybrid inverter. So an example is a Solarc. A Solarc is a hybrid inverter that can couple solar onto the DC side. It couples batteries, low voltage DC at 48 volts, and then it turns into AC. And on the AC side, you have grid and load, and in theory, generator as well on the AC side of that transformation. And a Solarc is stated to be able to pick up load in a grid service interruption in 10 milliseconds. So usually they say that that's fast enough that the lights won't even flicker and the clocks won't reset. And I know that to be the case because that's the one that we put in my brother's house. We also have a big grid disconnect out on the outside of the house. And on many occasions, we've done tours and thrown the disconnect. And it is true, the lights do not even flicker. You don't even notice the grid is gone because the inverter has the capacity to cut away the grid in an interruption and pick up and serve load with the battery and solar in such a small amount of time you won't even notice it. Generators can either have an automatic transfer switch, sort of like what's built into that inverter, or they can have a manual transfer switch. An automatic transfer switch on a generator does have to tell the generator to start doing combustion to make the electricity. And so it's not quite as fast as 10 milliseconds. I think they usually say something in a few seconds is usually the time that's quoted from sort of combustion generators with an automatic transfer switch. Or then the next thing after that is a manual transfer switch. The lights go out, you go down to the panel, maybe you disconnect the grid and then connect the generator and then push the start button. And so the time there is, as long as it takes you to do that operation, could be a minute or two maybe, right? But that's sort of the range. 10 milliseconds for a hybrid inverter, a few seconds for an automatic transfer switch, a few minutes for a manual transfer switch. But all three of those cases, then they can serve load and provide power and energy for what you have the capacity to do.
anything to add to that, John?
Not really, I guess. The generators, home standbys, it's a couple minutes because they're not critical base generators that switch really quick. But I mean, that doesn't really mean anything. Generators, if you do anything you do with an automatic, you have to be able to do load calculations to prove that your backup power system can power the loads in your panel. If you do a manual transfer switch, you're on a farm or something like that, then you can install a smaller generator, power your whole house, i.e. power that whole electrical panel, and then you manually go in and turn off the circuits to keep from overloading it. But if anytime it's an automatic operation, you have to do load calculations and prove that when it switches over in that 10 milliseconds, that it can continue to power the loads, that it doesn't shut off because it was overloaded, because somebody snuck in an electric water heater, then it popped on and overloaded the system and it shuts off. So
there's one thing I'd love to add to this conversation is please, please, please work with a professional that you trust. I have been involved in there are new technologies coming to market, right? Plug-in solar is now coming to market, and it is not quite at the stage where I would recommend people start doing this. But the other one is people start to think they can DIY this, and they start to do things like backfeed a generator into their main service panel. And there are ways on the internet that will tell you that this is reasonable. And I would severely encourage you not to tempt yourself with that kind of thing. There's a little metal plate that sort of is supposed to be a breaker override that forces you to use the main breaker as a grid disconnect before you can connect the generator. And that sounds like a good idea. And I really would encourage you, please, please work with a professional. If the grid is serving load onto a backfeed circuit that is on a generator, the generator will very likely catch fire. And depending on where that generator is and how much fuel is in it, you could have a very serious safety risk to person and property. Please don't tempt yourself with DIY backfeed stuff. I have people constantly ask me that kind of thing. Please don't do that. Please work with a professional.
Safety, follow the electric code, having a professional that knows that. Absolutely. Very, very, very important. Let's just finish this part of the conversation with, now we're that same user and the power came back on. What am I expecting to happen? Does it automatically just turn back on and I don't, or do I again have to do something? Just talk about that scenario just briefly.
So going in order again, for the fastest, the sort of hybrid inverter like a SolArc, I mean, it will once again immediately reconnect the grid. When it detects voltage and frequency stability on the grid, it will use the built-in automatic transfer switch, reconnect the grid on the AC side and serve load from the grid. Once again, lights probably don't even flicker. With an automatic transfer switch on a generator, you will have, as John said, something a little bit slower, many of seconds to few of minutes, where the generator will notice the grid is back, the automatic transfer switch will flip over from generator to grid, and then the generator will power down. With a manual transfer switch, once again, it's as fast as you do it, but it's pretty much the reverse of the other process.
Let's talk about batteries. We can get on the internet, we can find tons and tons and tons of batteries, but let's just talk a little bit about batteries and maybe some differences. What I'm really interested in is making sure that we understand maybe a little bit of the differences between maybe low voltage and high voltage, and maybe just a touch on battery chemistries, maybe the most common and the most popular at the moment. But obviously we could list just to get this started, but lead acid, the old kind of standby lead acid, lithium ion, and then I think when I'm reading a lot more lithium iron phosphate. Those are kind of three. If you can add, if there's any more that we need to add to that.
Now that pretty well covers what's in the market right now. I will note that lead acid is definitely well past its prime in terms of where these are used in the market. There may still be some cases for that. But yeah, lithium iron phosphate is the common chemistry essentially from any brand that Enphase or APS or Tesla or SIG Energy or anybody that we would have. They all use lithium iron phosphate for the batteries just because of cost and safety and capacity for both power and energy. It's a really good balance, and they are continuing to improve that technology. But that's the mainstay of the batteries that we see through our office and through installers that we work with.
And low voltage and high voltage. So
yeah, sure.
How does that define that? What does that mean? And then why are some have high voltage and some have low voltage?
Yeah, sure. So batteries are all DC direct current. So it's that loop from one end to the other, positive, negative, a one directional loop. And you can either add things in series or you can add things in parallel. If you put things in series, you will increase voltage for the same amount of current, essentially. If you put things in parallel, you will increase current and stay at the same amount of voltage. So if you take batteries and start stacking them in series, you will start upping the voltage. And we call low voltage, the common one right now for example, SolArc or EG4 hybrid inverters, low voltage is 48 volts of DC. By comparison, a car battery, a lead acid car battery is 12 volts. So if you put 4 of those wired in series, you would have those 48 volts. And I have been told from field applications engineers at SolArc, in theory, you could put 4 car batteries together in series and put them on the DC bus of that inverter, and you would have batteries on your SolArc. That is not a cost-effective way to do that, and you're going to get terrible performance. But that's what low voltage is. High voltage, instead of running in parallel, runs the battery cells in a longer series, and you get to a couple of 100 volts of DC. So that's usually what the high voltage conversation is about. That would be comparable to string inverters also run your solar panels in series and get to maybe a couple of 100 volts of DC. I will make a quick note that a couple of 100 volts of 10 or 20 amps of DC, when you touch or break a circuit, the metal at the very last seconds between connection of either making or breaking a connection can make an arc, and a DC arc flash is a very serious electrical event. So using the right hardware, the right equipment is essential, because a couple 100 volts of 10 or 20 amps of DC, it will vaporize the metal. It's hot enough to melt and vaporize copper instantly, and can even cause what is essentially smallish explosions. And there are blinding risks and burn risks and fire risks here. So working with a professional is the best way to make sure you appropriately mitigate the safety risks there.
Go ahead, John.
Okay, get into low and high voltage. So it's all dictated by the inverter. It's all dictated by the output of the inverter. So if you're putting an inverter in your RV that's a 2000-watt inverter, it's typically always going to be a 12-volt inverter. If you're doing a residential application, you're going to be at 48 volts because your capacity of your inverter is going to be at 12,000 watts. And so you can't pull that much current through cables of that size. Even a 12,000-watt inverter is still going to be running at 250 amps. And so you're using very large cables. You can't really go much bigger. So you are seeing there are some of the inverters that do have grid-tied inverters that have a backup option to a grid-tied inverter, and they run a higher voltage. SolarEdge did it forever, and then just like a 400-volt battery, but it matches their architecture of their 400-volt system. You get into larger three-phase inverters, you'll see those as an example, the Solarc, then it goes to a high voltage battery. It's more efficient, smaller cables. So, but you are seeing now, and there are some announcements in the residential world where they're looking at larger inverters, and so they're looking at they started developing 100-volt DC batteries for residential. So you're going to see the residential eventually continue to climb just because it's so much easier to build, so much less cabling. The cabling is it's more efficient. So you're going to see that. It's not going to eliminate the 48-volt systems at any time soon, but you're going to see things evolve into those higher voltage systems. But it's always based on the inverter, and yeah, you don't want to DIY that.
So I guarantee we could be just continue this conversation all day, but we don't have the time for that. We want to get to some questions. So what I want to do is ask one last kind of thing to comment on or question, and then we're gonna go to questions. So let's really think about put your maybe installer or designer or hat on and say, what do you really want customers to know when they come and seek backup systems? What are some of the maybe the main things that you're going to tell them that are most important?
For me, it's kind of like I said before, define your outage. Is it a 1 hour outage, a 1 day, a 1 week, a 1 month? What do you want to protect yourself against? List what you need to have. And then from that, we can design a system and adjust it accordingly. A lot of times people's needs change as they start to see what it may cost to do that. And longer outages are going to cost more money. That's it. And if you're small, as Scott said, he's in an apartment, right? So you could go buy one of those portable solar unit or portable battery units, just battery and inverter, because your goal is to keep the TV and your cell phone charged up. And it just sits there the size of a book box. That's perfectly acceptable for that particular scenario. Now you move on to the next guy who's got an acreage, lives on a well, got a well pump, gas furnace. He wants to do more. It's going to grow. And not one technology, whether it's a generator, solar, batteries, is going to serve every customer because every customer's needs and goals are going to be different. So define your outage. What do you want to run? And what do you expect it to do? What's the expectation? If you can meet the customer expectation, you've done your job.
Yeah, I would echo that. I think that's sage advice from an experienced professional. There are several levers we can pull for trade-offs, right? User behavior versus smart circuits and monitoring, right? I sell solar hardware in my day job. I would be glad to sell you enough batteries to power unlimited demand with no user behavior changes for a week, right? If you've got $275,000 you want to spend on a battery system, I would be glad to sell that to you. I would love to encourage people to work with someone you trust to come to a place that makes sense for you. Right? I think that's maybe the most important thing is to have some reasonable expectations and then also work with an experienced professional that you can trust to help you get to a place that you feel comfortable with. Because you want to be able to be happy with the investment because these are going to be, probably for most people, this is a sizable investment if you're looking to do this. And so working with an experienced professional that you trust and having reasonable expectations in that conversation, I think is the most important thing I would encourage.
Yeah, great. Professional help, realistic expectations, really important. Thank you both for joining me today. We're going to wrap this one up. We do have a webinar next week. We're going to have the same two John and Scott show here, and we're going to talk about off-grid systems, and that's just a little bit different animal. And because of that, it's going to be a separate webinar. We're going to deal with trying to have these systems run all the time, and that's just going to be a little bit of a fun conversation. So join us for that next week.